Welcome everyone. If you're watching this video, you might looking for example on modified algorithm where you're in luck because we're going to present to you the modified shell sort algorithm in data structure and algorithm. But before we start, let me introduce to you to my co-member for this project, Miss Crystal Jeb Dumulot, Alexandra Fontesilia, and me, Mr. Alexis Don Pagaduan.
Data structure, a way of organizing data so it can be used efficiently. Common data structure include arrays, linked lists, and binary lists. Think of data structure is like different types of containers for storing and organizing information. Each type of data structures has its own strengths and weaknesses, similar to how you might choose a bag, a box, or a shelf to store different kinds of items in them. For example, the image on the left side is an array. An array is like a list where items are placed in a specific order and you can quickly access any item by its position in the list. It's like having a row of labeled boxes where you can easily find what you need. Then on the right side, there's the binary tree, which is like top-down structure where each item has at most two children. It's great for quickly searching for specific items because you can efficiently narrow down your search by following branches. Each data structure has its own unique way of organizing and accessing data efficiently. Depending on the operations you need to perform, just like choosing the right tool for the job, picking the right data structure can make your programs more efficient and effective. Next is algorithm. Algorithm is a process or set of rules to be followed in calculations or other problem-solving operations, especially by a computer. When we talk about an algorithm, we're essentially talking about a set of rules or instructions that guides the computer through particular problem-solving process. It's like a recipe that a computer follows to perform calculations or solve problems. The picture below is an algorithm. The input. User provides some initial input to the system. User will provide a number as the input in the algorithm that the system needs to process. The inputs serve as the starting point for the algorithmic process. Set of rules to obtain the expected output from the given output. The system follows a set of predefined rules or instructions to process the user input. This will define how the system should interpret, analyze, and respond to the input provided by the user. The rules outline the logic, operations, and decision-making process that the system uses to transform the input into desired output. Output. After applying the rules to the user input, the system generates an output or response. This output could be a result, feedback, action, message, display, or any form of communication or outcome that the system produces based on the user input and the rules it follows. The output is the system's way of providing relevant information or performing the request task for the user. In this algorithm process, the user inputs a number. The algorithm applies a specific rule to manipulate the input data. And finally, the output produced based on the rule. What is the sorting algorithm engaged in? A sorting algorithm is a type of algorithm that sorts the element of a data structure in certain way, most of the time in ascending order. The sorting algorithm refers to the various methods used to rearrange a given array or a list of elements according to a comparison operator of the elements. These algorithms are essential for organizing data efficiently, making it easier to search, retrieve, and analyze information. There are few commonly used sorting algorithms. A common sorting algorithm is the bubble sort, selection sort, insertion sort, and the last, shell sort. These different sorting algorithms each with its own advantages and disadvantages. In terms of efficiency, simplicity, and stability, each of these algorithms has its own characteristic and performance trade-offs. The choice of sorting algorithm depends on factors such as size of the dataset, the nature of the data, and the required efficiency of the sorting process. What is the shell sort? Shell sort is a sorting algorithm that is highly efficient and is based on the insertion sort algorithm. This algorithm avoids large shifts as in insertion sort where the smaller value is on the far right and must be moved to the far left. Shell sort reduces its time complexity by utilizing the fact that using insertion sort on a partially sorted array results in fewer moves. This is achieved by initially sorting elements that are far apart from each other and progressively reducing the gap between elements to be compared by sorting elements separated by larger gaps. The algorithm effectively moves elements closer to their correct positions, creating partially sorted arrays that are more efficient for insertion sort process. This incremental approach of reducing gaps, known as diminishing increment sort, allows shell sort to overcome the limitation of simple insertion sort, particularly on large datasets, leading to significant improvements in performance.
So how does it work? For example, we have an array of 12, 23, 5, 9, 10, 18, and 3. First up, we need to find the value of gap. We're going to use this formula, size floor division by 2. After getting the floor division, we're now proceeding to the loop. In the loop, it will still going to continue to run the code until the gap is less than 0 or equal to 0. In the middle loop, it will use a temporary variable which will store the array in index I. And j will be equal to the value of I. Within the middle loop, we'll have the innermost loop, which is the while loop. In this while loop, it will check if j is greater than or equal to the gap, and if the array j minus gap is greater than 10. If those conditions has been met, then the two number will be swapped. Now we're going to move on to the next index. We're going to check the temporary value, 23, with the array j minus gap, which is 10. If 23 is greater than 10, then we're going to have to swap the two values. And we're going to move on to the next index. Same process, we're going to check if the temporary value 5 is greater than the j minus gap. Since 5 is less than 18, we're going to move on to the next index. We're going to check if 3 and 12 supports the conditions. Since 12 is greater than 3, we're going to swap them too. Now, as you can see, every time the iteration of the innermost loop has been done, the gap is equated to j minus gap, which means we're going to go back to the index 3. We're going to check if index 3 is less than 9. Since 9 is greater than 3, we're going to swap the two values. Now, we have finished the middle loop. We're going to move on, where gap is floor divided by 2, which makes the 3 divided by 2, which is equals to 1.5, equals to index 1. So we're going to check every gap of 1. We're going to repeat the whole iteration, checking 10 and 3. Since 3 is less than 10, we're going to move on to 5. Since 10 is greater than 5, we're going to swap. Now, here's the twist. Since j is equals to j minus gap, we're going to go back to 5 and check if the preceding term is greater than 5. Since 3 is less than 5, we're going to move on to the next index. Checking 10 if greater than 9. Since it's true, then we're going to swap. Then the whole process repeats. As you can see, the number from 3 to 10 is already sorted, so we don't have to swap any values. we're going to move on to 23. As you can see, from 3 to 23 is already sorted, so it's only going to check if everything is on order. Moving on to 18, checking if 23 is greater than 18. Since it's true, then we're going to swap. And as you can see, from 3 to 23, they're already been sorted. We're going to move on to the next iteration. Moving on to the index 6, 23 is greater than 12, swap. 18 is greater than 12, swap. And as you can see, the whole array is already been sorted, so it's just going to complete the process by checking every single preceding terms. Now, since the for loop is been succeeded, we're going to divide the 1 by floor division by 2, which equates to 0.5, which is already making the whole statement false, which finishing the outer loop. So there you have it. That's how shell sort works. So how did we modify it? Before modification, we use this formula. Before the loop, we're going to get the gap by finding the size and floor divided by 2. And while in the loop, the gap will keep on divided by 2 and getting the floor division. After modification, we change all the formula by the following sets. Before the loop, we find the gap by size, floor divided by 4, and equate it to the other gaps. While the loop is running, all the gaps will be floor divided by 4. So what does it do? While using the original formula, it will take more iteration of the outer loop before it gets sorted, since in one iteration, it only do one gap. But in our modification, it can do up to 4 gaps in one iteration. On that fact that it's still going to compare each element of the array as much as before. Here's our pseudocode. As you can see, we first equate all the gaps into 0. Then, the size is equals to the length of the array, and the gap 1 is equals to size floor divided by 4. And then we equate all of that for the rest of the gaps. Then we run the outermost loop, the while loop. Until the gap is less than or equal to 0, it will keep repeating these 4 different functions, which is this one. As you can see, it's the same as before, except this part. Is this part? Since we need to check if the highest point of the index is not equal to the length of the array. If so, if it is equal, then the rest of the code will cause an error. Then after the outermost loop is been run, then it will floor divide all the gap by 4.
Advantages. First, it takes less iteration of the outer loop to sort the whole array with a larger amount of elements. As previously discussed by Mr. Pagaduan, our modified algorithm will reduce the iteration of the outer loop. The second one is allow us to edit the code for more gaps for bigger size arrays. It allows the other developer to add more gaps for bigger size of array. Limits. The first is, the more gaps there are, the bigger the minimum size of the array is needed. For 5 gaps, it needs at least 16 elements. The more the gap you use in this type of modification, the bigger the required size of the array. Second one, a bit more complicated than the original shell sort algorithm. This adds more depth in the code, which might be harder for young coders.
Let us show you how the modification was implemented. This is our code. As you can see, we use 3 different sets of functions. The first function is the traversing function. The next one is the innermost loop function. And this last function is the outer most loop. And this is our initial code. Now let us try using this set of elements in one array. As you can see, the number of iteration only takes 2. While in the original shell sort, it will take 4 iterations. Let me show you. In the first iteration of the original shell sort, it used this much of. Let me show you what does it look like in the original shell sort. In the first iteration, it will do this much of comparing and swapping to reach to this point. As you can see, it's still not sorted. So we will go and move on to the iteration 2, which will do this much of swapping and comparing to the point which reach this set of array, which still not sorted. So it will move to the iteration 3. Still not sorted, and iteration 4. Now it's finally sorted. As you can see, we now printed the last part here. Now let me present to you the modified shell sort. It has also the same functions except for the last function, it will use the modified formula. As you can see, when we use the same set of arrays, it will only use 2 iterations. But it should also have the same amount of swaps.